everyone. Today we are going to talk about the materials, their properties, states of matter, and the changes in the states. Let's take a look at what's there to learn today. We'll talk about the states of matter, the particle theory, properties of states of matter, thermal and electrical conductor, and we'll just have a quick touch and go about the changes of states. Let's take a look at states of matter. What really matter is? Basically, everything that you can see or feel around you is called as matter. Everything that exists physically around us is called as matter in a scientific term. That includes even the air, the water, woods, stone, metals, and every other physical substance around us. Based on how this matter behaves, scientists have sorted the matter into three groups or states, which are called as solids, liquids, and gases. So the three states of matter are solid, liquids, and gases, sorting the entire physically existing substance around us. Let's talk about the particle theory. Basically, how the matter behaves is been defined by the best theory, which explains how every matter behaves, uses the idea of the particle. The particle, which is the tiniest, most portion of a matter. The key ideas of particle theory are revolving around the particles into a given matter. It indicates all matter is made of tiny particles which are too small to even see. Particles are always moving. There are obviously some spaces between the particles. The particles attract each other. There are certain force of attractions acting between the particles. Heating increases the movement of the particle and cooling decreases the movements of the particle. Let's take a look at how the particle theory explains more the states of matters, that is solid, liquid, and gas. So for solid, the particles are tightly packed. That's why you see a fixed shape. Every particle is moving always, but the particles in solid, they vibrate in the fixed position. Thus, they are forming a fixed shape and volume. When it comes to liquids, the particles are close together but not very much tightly placed. Thus, the particles can move past each other and make the liquid flow. Liquid always has a fixed volume but does not have a fixed shape because the particles are close enough but not so tightly packed to form a shape. About the gases, again, the particles are far apart from each other, very less forces of attraction acting on the particles. Thus, the particles in the gas are moving freely and quickly in all directions, thus making the gas having no fixed shape or no fixed volume. As you see, the particle theory is describing a particular state of matter, whether it is solid, liquid, or gas, based on how really the particles within that matter is behaving. Let's take a look at the properties of states of matter a little bit in depth. Properties of solids. All the properties are inheriting based on the particle behavior inside a given matter. When we say solid, the particles are very close together, thus making it difficult to reduce the volume of a solid by compressing it or breaking it or to cut into pieces. You would need some force to be applied in order to make these particles move away from each other, because solids are really closely packed and are having a fixed shape. The fixed shape actually is there because of the high attractive forces between the particles. As the particles are very closely placed, though every particle is moving by the particle theory, the particles still move, but they just vibrate at a given place, thus making the shape of the solid remain intact. And obviously, this does not let the solid to flow, unlike liquids. Let's take a look at properties of liquids based on the particle theory, but a little depth. The particles in liquids are close, but they can still move. They don't need to vibrate, they can move because they are placed together but not so tightly packed. They can slide past each other. As the particles are not tightly packed and placed with each other, liquids do not have a fixed shape. The attractive forces between particles of liquid is weaker than in solid. Thus, we see that the liquids can flow and they do not have a fixed shape. A liquid cannot be compressed though, because the particles are there moving around each other, sliding past each other, thus not letting it to be compressed and making it flow. Properties of gases. Unlike solids, particles in gases are far apart from each other, having less or no forces of attraction, move freely and quickly, thus do not have a fixed shape and the volume. The gases can be easily compressed though, unlike liquids. Let's talk about the thermal and electrical conductors. Conduction is basically the energy transfer between the objects. The thermal conductors or the electrical conductors are being identified based on the property of material or matter, whether they can transfer the energy through them. So, thermal conductors are materials that allow the heat to pass through them easily. In this example, we see that there's a hot tea which is a source of heat, and we see the spoon placed into the tea, which is made up of, let's say, steel. And you see the heat energy from the tea is being transferred towards the colder end of the spoon. Thus, the spoon is actually letting the heat flows, and the spoon is made up of metal, maybe a steel or copper, and that's why we say that the material here is the thermal conductor of heat. So the heat from the hot tea passes through the metal spoon from the hot end to the cooler end. This is nothing but the thermal conduction. Let's move to the electrical conductors. Electrical conductors are materials that allow the electricity to pass through them. Mostly, the various metals are being used to form the wires which are used in electrical circuits. When a circuit is complete, the free electrons move through the conductor, which is the metal wire in this case. As the metal wire allows the electricity to flow through it, we call the metal wires are the electrical conductors. The good conductor let the electricity flow easily because they have the free electrons within them. Moving towards the changes of state, we are going to discuss this in brief, how a change of state happens and what exactly is a change of state. A change of state basically happens when a material changes its own form. That is, a solid is getting converted into a liquid, or a liquid is getting converted into a gas, and for that sake, even a liquid getting converted into a solid bag. For this change of state to happen, we need to have either heating or cooling processes being used. So, heat energy has to be either added or removed from the particles of the matter in order to change the form. The main changes for the state could be melting, that is converting a solid into a liquid, freezing, converting a liquid into a solid, evaporation, that is liquid converting to gas, and condensation, that is gas is getting converted into a liquid. Let's understand more how the change of state happens. We'll talk about the change of state of matter primarily around three things: solid to liquid, that is called as melting; liquid to gas, that is called as evaporation; and liquid to solid, which is called as freezing. When a solid is to be converted into a liquid, we are going to add the heat energy. What happens when the heat is added to the solid ice here? The solid particles absorb heat and they start moving away from each other. When the particles are moving away from each other, the solid is changing its form into liquid, and the matter is absorbing the heat and acquiring the properties of liquid. That is, particles are moving away from each other, they are sliding fast over each other, and thus making the matter flow. What is this? A matter which flows, the particles move and pass slide each other. It's a liquid, right? So you have a change of state here from solid to liquid by addition of heat energy. In the second example, we have the liquid to gas, which is called as the process of evaporation. In this, again, we add the heat energy to the liquid matter. When the liquid absorbs the heat, the particles within the liquid would start moving far more away from each other, thus acquiring the properties of gases. As the water starts evaporating, we call it that it is getting converted into a gas and the liquid state is being changed into a gas state now. Coming to the third one, that is liquid to solid, we call it as freezing, and this is an opposite process of your melting, right? So in liquid to solid, we are actually removing the heat from the liquid. When the heat is being removed from the liquid, the particles would try come closer to each other, thus being tightly packed and forming a solid ice. And that's where you see that a liquid state water is being changed into a solid state, forming an ice, giving a fixed shape, particle tightly packed with each other, and thus we call it as a state change from liquid to a solid state of matter. When we talked about the state of matter, the primary part of it was adding the heat. Based on the heat being added to a material, there are properties for material which are the boiling points and the melting points. So melting point is basically a temperature at which solid becomes liquid. So when an ice is heated, it melts at 0 degrees Celsius. So 0 degrees becomes the melting point for ice. Similarly, the temperature at which the liquid particles have enough energy to convert into gas is called as the boiling point. So pure water, when heated and we are adding the heat energy, it boils when the temperature reaches 100 degrees Celsius. Thus, we call the boiling point of water is 100 degrees Celsius. There are some quick facts which are good to know and would make your understanding better around how the states of matter are being defined and how the boiling points and evaporation are going to be considered for a state change. Boiling and evaporation are basically two different processes. So when liquid boils, the particles are going to get enough energy to convert into gas, but they are not actually converting into a gas. So the liquid boils, but only the particles on the surface of the liquid are actually changing into gas, and that is called as evaporation. A liquid which is in its own form, but the particles are heated up towards 100 degrees and make the liquid boil, that is just the boiling but not really the evaporation. Similarly, when we talked about the states of matter and the behavior of matters, scientists observe and try to explain how a substance or a matter behave, how the particles are behaving, how a certain matter is being considered as solid, liquid, or gas. They think about why certain things happen into a material or a matter and try to come up with ideas to explain it. This is nothing but the formation of a hypothesis. And hypothesis is nothing but a suggestion for an explanation. A hypothesis is not always going to be considered as a theory because hypotheses are just the observations and explanations about certain behaviors of the matter. They are not something which are widely accepted. But when the hypothesis has been tested and widely accepted by other scientists, then it is called as a theory and then it is considered as a standard to be applied for explaining certain behaviors, just as a particle theory that we discussed about. All right, so that's what pretty much I had. Great job today, guys. We covered the materials and their properties, states of matter and particle theory. We talked a little bit about thermal and electrical conductors and a brief on change of states. Are you ready to test yourself? You have a quiz link in the description. Try yourself out. Do post your comments and suggestion to us. Thank you so much.